Lesson 0.4, Units. In physics, correct answers, so in order to get an answer marked right on a test, you must have correct significant digits, which means you must follow significant digit rules for every calculation you do, as well as the correct units. You must provide a unit for every answer that represents a measurement. For example, an answer might look like D equals 5.0 meters. The D is a symbol. We use this to indicate or show which physics quantity or which kind of measurement we are looking at. The 5.0 is in correct significant digits. It has two significant digits to represent the precision of our measurement. And the meters is the unit. In physics, we have base units, and in Physics 20, we will use 3 base units. These are the official units for length, which is the meter, time, which is the second, and mass, which is given by the kilogram. All other units in physics are constructed. They're built like building blocks out of the base units. We call these constructed units or built units the derived units. And most units you'll work with in physics are actually derived units, even though it may not seem like it. Here's some examples of some derived units that we use in physics. For speed, we construct units by examining the speed formula, v equals d over t. The base units are d, which is meters, and t, which is seconds. The derived unit that's constructed for velocity is therefore meters over seconds, or meters per second. Acceleration also has a derived unit. In physics, acceleration has the formula a equals speed over time. Speed has a derived unit, meters per second, and time has a base unit of seconds. This means we can derive a new unit for acceleration of meters per second over seconds, which equals meters per second squared, which is the derived unit for acceleration. Force, F, is given by the formula F equals ma. Mass has a base unit, which is kilograms, and acceleration, we've learned, has a derived unit, meters per second squared. Combining these two units, as it looks in the formula, force looks like it should have the unit kilogram meter per second squared. In fact, this is the official derived unit for force. But this unit is a little bit big. It's getting a little cumbersome to work with, a bit long to write out every single time you want to write it. If you have to write out kilogram meters per second on every time you calculate force, it gets a little long. So scientists created a unit to take the place of the kilogram meter per second squared. They gave the unit kilogram meter per second squared a short name, or a shorter version, and this is given by the letter N, which we call the Newton. But the Newton is not an official unit or a base unit. It's actually a unit that's been derived out of the base units of kilogram, meter, and second. Now, In physics, we use the metric system. And to use the metric system properly, you need to know the metric prefixes. I'm going to give you a couple here. In the center is the base. The base gets larger with K and M, which is kilo and mega. Gets smaller with centi, milli, and micro. C, M, and Greek letter mu. Centi is 10 to the minus 2 of the base. Milli is 10 to the minus 3, and micro is 10 to the minus 6. Kilo is 10 to the 3, and mega is 10 to the 6. These 10 to the numbers represent the metric conversion factors. We'll use these conversion factors to turn prefixed units into the base unit and base units into prefixed units. Here's how. To change from a prefixed unit to the base unit, you multiply by the conversion factor. For example, 700 micrometers to meters. So we multiply 700 micrometers by the conversion factor, which is 10 to the minus 6 meters. This looks like scientific notation, but we need to convert it so there's only one number before the decimal. Move the decimal over 2 places and add 2 to minus 6. 2 plus minus 6 equals minus 4. So the answer is 700 micrometers equals 7 times 10 to the minus 4 meters. To change from a base unit to a prefixed unit, you divide by the conversion factor. For example, 2,000 meters to megameters. Mega is 10 to the 6 meters. 2,000 meters divided by 10 to the 6 is 2,000 times 10 to the 6, or negative 6. This looks again a little bit like scientific notation, but to make it proper, we move the decimal over so there's only one number in front. We moved it 3 times, and 3 plus minus 6 is minus 3. So we can write this out as 2 times 10 to the minus 3 megameters. Now, there are some special cases, or special conversions that you need to know about. You need to be able to convert from seconds to minutes to hours. We know there's 60 seconds in a minute and 60 minutes in an hour. And because of this, 60 times 60 is 3600, and there's 3600 seconds in an hour. Now, seconds is the base unit, which means that to convert seconds to one of the greater units, we divide. Seconds divided by 60 equals minutes. Seconds divided by 3600 is hours. Hours times 3600 equals seconds, and minutes times 60 equals seconds. You also need to be able to convert from kilometers per hour to meters per second, and meters per second to kilometers per hour, to show the different kinds of speeds we use. Kilometers per hour can be converted like this. Kilometers times 1,000, and remember 1,000 is the conversion factor for a meter to kilometer, which is 10 to the 3. So a kilometer times 1,000 will give us a meter using this conversion factor. An hour times 3600 will give us a second. 1,000 over 3600 is the same as writing 1 over 3.6. 1,000 divided by 360 is 1 over 3.6. So divide by 3.6 to go from kilometers per hour to meters per second. The 3.6 appears also when you go from meters per second to kilometers per hour. A meter divided by 1,000 gives a kilometer. A second divided by 3600 gives an hour. Dividing by 1,000 over 3600 is also like dividing by 1 over 3.6. And divided by 1 over 3.6 is the same as multiplying by 3.6. So a meter per second times 3.6 equals a kilometer per hour. Here's an example to get you to understand what we're doing. 100 kilometers per hour to meters per second. 100 kilometers per hour divided by 3.6 will give us meters per second. This is 27.7 repeating. Now, this is not in the correct significant digits, so next we have to do significant digits. 100 has 3 significant digits, and 3.6 is an exact number. So don't count it towards the significant digits. Our answer must have 3 significant digits. We round the 7 up to 8. So 100 kilometers per hour is 27.8 meters per second.